Greetings, geometry students. Today we're going to take a little bit of a deeper look at some of the properties that are inherent in all triangles. Please copy down your title, Foundation Properties of Triangles. The date for these lessons will be Thursday, December the 4th, and please copy down your objectives as well. Our stated objective for the day is to discover the relationships between the angles and the sides of all triangles. Language objective is a little lengthy. Fortunately, you don't have to copy it down, but this is what we'll be doing on our assignment. We're going to demonstrate the ability to apply new triangle relationships and rules in order to answer questions regarding the structure of provided triangles, and then to categorize those triangles based upon the discovered information. Your essential question for today will be, can I apply the new triangle rules? Some of these rules you might be familiar with, some of these rules you might not be familiar with. They are not difficult, but they are important to what triangles do. So let's take a look. Now obviously all triangles carry certain properties with them. I do believe I misspelled certain right there. I think it should be A before I. Anyway, triangles carry properties with them. In fact, they carry a lot of properties with them. We're going to be spending a good amount of time from now until the end of the year focusing on nothing but triangles. Okay, so the first thing we're going to take a look at is the angle and side relationships. Now, we kind of hinted at it yesterday or the last time that we talked that there was a relationship that connected information about the sides of a triangle and information about the angles of a triangle. Actually, there's a lot of mathematical information that does connect them and several formulas that do connect them mathematically, but today we're just looking at a general relationship. And that relationship says in any triangle, the smallest angle and the smallest side have a relationship with each other, as do the medium-sized side and the medium-sized angle, as do the largest side and the largest angle. And the relationship between all three of these pairs is that they are always positioned across the triangle from each other. And if you get to thinking about it, that actually makes perfect sense. If you have a small angle on one side of the triangle, then it does not get to open up very much. So caught between the legs of that angle, there's not going to be much room for a lengthy side of the triangle. Whereas if you have a large angle, the legs of that angle are wide open, so you have a lot of room for a third side of the triangle. Okay, but that's the relationship. The smallest angle and the smallest side always across from each other. The largest angle and the largest side always across from each other, and so on. And this goes for ties as well. If you have two sides that are exactly the same length, that means you're going to have two angles that are exactly the same measurement across from those sides. All three sides the same is going to force all three angles the same. Okay, so let's take a look at a basic example here. We have a triangle. The name of this triangle would be, if you'll remember yesterday, triangle ABC. Got to list all of the vertices. We can list them in any order we want. Could be triangle ABC or ACB, BCA, BAC, BC, or CBA, CAB. All would be accurate descriptions. At any rate, we have triangle ABC. The side lengths of this triangle are unknown, but we do have all of the information about the angle measurements. Well, we're going to be able to use those angle measurements in order to predict what is going on as far as the lengths of the sides. The question is, which side of the triangle is longest? Okay, well, based upon the angle-side relationship up above, the largest side of the triangle will be positioned directly across from the largest angle of the triangle. Well, obviously, the largest angle of the triangle is the angle at vertex C. So angle ACB would be a name for that one. Okay, and across from angle ACB is the side of the triangle that is marked with the small red C. Okay, so since it has a name, in this case, we can call it by its name, side C. If it didn't have a name, we would call it line segment AB. And again, side C is the longest because it is across from the largest angle, which was angle ACB. Okay. Another example. This time we are provided information about triangle ABC's sides. And then we are asked a question about what is going on with the angles. Particularly, we want to know which angle in triangle ABC is the smallest of the angles. Well, as before, with the angle-side relationship, the smallest angle in the triangle is going to be positioned across from the smallest side of the triangle. Well, very clear to see that side BC is the smallest angle of the triangle because of the measurements, not because it appears smaller, but it is clearly the smallest measurement, and the angle that is across from side BC is the angle that is positioned near vertex A. So we would say that angle CAB, or you could spin that around and say angle BAC, is going to be the smallest angle. And our reason for that response would be because it is across from the smallest side, which was side BC. Another example here. Okay, we're going to tie the information that we are picking up today back to the information that we did on the first day of the unit, which would be bringing us back to classifying the triangles. Many times, all the information that is needed in order to classify a triangle is not provided to you right off the bat. So what we have to do is we have to figure out any missing information that may be needed but is missing from the problem so that we can fully classify the triangles. Now remember that we have 7 terms, 7 different classifications for our triangles. We have 4 that describe the angle measurements of our triangles and 3 that describe our side lengths of our triangles. In all cases, you will find at least one angle descriptor, at least one angle category, okay, but it could possibly be 2 different angle categories. And you will find at least one side category description, and it is possible that a triangle may fit into 2 categories for side lengths. Okay, so classify the following triangle. So let's see what we know about this triangle. Let's take a look at the angle measurements first, since that's what we have readily available. Okay. We have 3 angle measurements, a 50-degree angle, another 50-degree angle, and an 80-degree angle. Okay, now we said all triangles will possess at least 2 acute angles. So if we remove 2 acute angles from the discussion, let's take away the 50 and the other 50 just to make it easy. Then we examine the remaining angle measurement, and whatever that measurement is should tell us what kind of a triangle we have. 80 degrees would be the remaining angle. 80 is smaller than 90. That is also acute. All 3 angles are acute angles. That means we have an acute triangle. That's going to be the only descriptor that we have for the angle measurements. The only other possibility it could have been, as well as acute, would be equiangular. However, not all of the angles are equal, so it is not equiangular. Let's move on to the side lengths. Now, none of the information about the side lengths was provided for us, but based upon the angle-side relationship rule that we just saw, we can predict what the side lengths will be doing as far as comparing them to each other. We have 2 angle measurements that are the same inside of our triangle. So let's figure out for a moment, what is it going to mean to the side lengths if there are 2 angle measurements that are the same? Well, by the rule, two angle measurements that are the same are going to mean that two side lengths across from those angles will also be the same. However, the third side length in question would be across from the 80-degree angle, and since the 80 is a different measurement than the other two 50s, that means that the third side, side AC, is going to be a different length than side AB or side BC. So two sides the same. The term that describes that is isosceles. Okay, there are no other categories that our triangle can fit into, so it is classified as an acute isosceles triangle. Okay. Now, the interior angles of a triangle have a rule that go with them, and I would bet everybody already knows this one. The rule states the interior angles in any triangle will always add to 180 degrees. This is a rule we should have picked up in junior high along the way at some point, and it's actually a small part of a much larger rule that we will be getting to later on. And you may be familiar with that one as well, but we won't worry about that now. For now, the interior angles in any triangle will always add to 180 degrees. Okay, so to put it into a diagram, okay, there's a triangle. The three angles in question are angle A, angle B, and angle C. Well, more specifically, A degrees, B degrees, and C degrees. And the rule says if you take the A degrees, B degrees, and C degrees and you add them up, the result of that addition will be 180 degrees. That is true all of the time. It does not matter what size or type or classifications of triangles you have. This rule always applies. Okay, so let's look at an example of that real quick. Here we have a basic right triangle. We have some of the angle measurements and some we do not, and our instruction is to solve for x. Okay. Well, always is the case in geometry. The real challenge is to be able to write an accurate equation, so when it comes time for us to solve, we are solving the correct equation. Okay, so let's look what we have here. X, obviously, is information dealing with one of the interior angles of a triangle. Okay, so we kind of ask ourselves at this point, do I have a rule or what do I know about the interior angles of a triangle? Well, of course, the three interior angles of a triangle are supposed to add together to be 180 degrees. So if we know any two of them, we can very easily find the third. Well, do we know two angles of our triangle? Of course we do. We have a 70 degree that is marked for us. We have the right angle box that is indicated in the picture, so that's at 90. And of course x is unknown. So the equation that needs to be written is 70 plus 90 plus the unknown x should result in 180. Now all you have to do is solve for x. Okay, so walk through your 5 steps for solving an equation. Parents' complaints vary for everyone. Okay, parents would be parentheses. We don't have any parentheses to deal with. Complaints is combining like terms. We do have some like terms that can be combined. On the left side of the problem, we have 70 and we have 90. Those are both just constants. There's no reason for them to be apart like that, so we can add them together. 70 and 90 is 160. Third step of solving the equations is vary. Okay, that means the variables. So we want all of our variables on one side of the equal sign or the other. That is already accomplished, so nothing to do there. Okay, fourth step of the steps is everything. That means everything else, the other direction away from the variables. Well, the variables already own the left side, so that means everything else needs to go to the right side. So there is no reason for that positive 160 to be there. So to move 160 to the other side, we do the opposite of positive 160, which is negative 160. And of course, whatever we do to one side of the equation, we must also do to the other. And that leaves x equals 20. So we do not have to worry about the final step of solving the equation, which is to get a 1 for the coefficient of your variable. We already have it. There was already only one x, and 1x equals 20. So that means we were missing a 20-degree angle from our triangle. Okay, I'm going to work out one last example for you here, and then I'm going to give you one to work on your own. In this case, here we have triangle ABC again. We have various angle information about triangle ABC provided for us. Obviously, some of the information is missing. And the goal of the problem is to find out what is the largest side of the triangle. Well, as we've seen several times in this lesson, if we can figure out what's going on with the angle measurements, then that will tell us what's going on with the side lengths. Okay. Well, one of the angle measurements is known to us. It is 25 degrees. Then we have two angles, one of them being 2y and one of them being 3y. It seems like 3y will be bigger than 2y, but it does kind of depend on the value of the variable y. And it's impossible for us to know at this point whether the 2y or the 3y is bigger or smaller than the 25 degrees that we do know. So obviously the goal is going to have to be to solve for y so that we can answer their question. Okay, but once again, the information in question is all about the interior angles of this triangle, and we know that 3 interior angles of a triangle will add together to equal 180 degrees. So that sounds like a good equation for us to write. The 25 that we do know, the 2y that we do not know, and the 3y that we do not know are going to add together to equal 180 degrees. Okay, so parents' complaints vary for everyone, parentheses, no. Combine like terms. Okay. Yes, we do have like terms to combine. There are 2 y's on the left and there are 3 y's on the left. They do not need to be apart like that, so we will combine them to make 5 y's. Get all your variables on one side of the equal sign. Well, that is already accomplished. And then get everything else away from your variables. Okay, so that positive 25 on the left does not need to be there. So the opposite of positive 25 is minus 25. So we'll subtract 25 from both sides of the problem to keep the problem balanced. That will leave 5 y's equaling 155. The final step is to get a 1 for your coefficient of your variable. Right now we have 5 y's. We do not want 5 of them, we just want 1. So in order to move the 5 but leave the y, we're going to divide both sides by 5. And that will give us a value of y equals 31. Now be careful, this is a typical tripping point on problems. A lot of people will put a circle or a box around y equals 31 and move on to the next problem. And if you do that, you just missed this problem because the problem did not ask you how big is y or solve for y. The problem asks you which is the largest side of the triangle. Well, we haven't figured that out yet. This is called a two-step problem because you have to solve one thing in order to be able to solve the next thing. Okay, so what we're going to do is we're going to take that y equals 31 and we're going to apply it to the triangle that we had. Instead of 2y, we'll take y out and we will plug in 31 for the angle near vertex C. And instead of 3y, we'll take the y out. We'll plug in 31 for the angle near vertex B. So all we really need to do is figure out what those measurements are. Of course, the angle near vertex A is 25 degrees. Now the angle near vertex C, 2 times 31 degrees is 62 degrees. And on the angle near vertex B, 3 times 31 is 93 degrees. Okay, based upon this new information, we can now answer the question of which side length is going to be the largest side of the triangle. The largest side will be across from the largest angle. The largest angle is near vertex B. The side across from that would be side AC. So side AC is the longest, since angle CBA is the largest angle. Okay, the final chore for the day will be for you to work out this example while this information is fresh in your head. Okay, so classify the following triangle. Okay, so we have triangle XYZ. Obviously, information about the angles is kind of provided for us. We have a lot of unknown stuff going on in there, but it works very similar to the problem that was just worked out with you in the notes. We need to figure out what is going on with x so that we can understand these angle measurements. Based upon the result of the angle measurements, we'll be able to figure out what's going on with the sides, and then knowing the angles and the sides, we will be able to classify the triangle. Okay, so I want you to take a couple of minutes and work out this problem and answer it. I do expect this problem to be completed and answered in your notes if you expect to get credit for your notes. And then the last thing for you to do will be to jot down a quick summary of what you're doing. And of course, always keep your essential question in mind. Can I apply the new triangle rules? If you can, you're doing fine. If you cannot, you have some more work that needs to be done. Okay. All right. Very good. I will see you in class.